we are learning the Pythagorean Theorem. Anybody ever heard the saying, the bark is scarier than the bite? Okay, so that definitely applies with this section. Pythagorean Theorem, you think, oh my goodness, this is going to be so hard. Look at that really complicated name. It's not that hard, okay? The hardest part about it is probably spelling it correctly. All right, Pythagorean Theorem. So, here's what you need to know about the Pythagorean Theorem. You need to write these points down. The most important part, probably, is going to be your formula. All right, so on tonight's homework, that's going to be the original problem that you write. You don't have to draw the triangles that are listed on the problems. The formula is your original problem. I want to see this formula on all of your homework problems tonight. A squared plus b squared equals c squared. The legs of the triangle form the right angle. The hypotenuse is the side opposite the right angle. And you see that in the diagram, that the legs form the right angle and the hypotenuse is opposite the right angle. Notice also in parentheses, we have variables that represent each leg. And you can remember them by thinking A for altitude, that's going to be the leg that is the height of the triangle. B for base, because that's the leg that's the base of the triangle. And then C is the hypotenuse, and we know that that leg is always opposite the right angle. Okay, so go ahead and just copy down. You pretty much have to copy down everything on this slide. It's all very important to understanding this section. All right, so in example 1, we're going to first solve for the hypotenuse. Okay, so we have side lengths of 15, 36, and C. All right, so those are our dimensions, and now we're just going to use our formula. A squared plus b squared equals c squared. That's always our original. What do we plug in for A? Yeah, 15, because that's the altitude or the height. 15 squared plus 36 squared equals c squared. All right, and then this part, I'm fine if you go ahead and just do 15 squared plus 36 squared in your calculators. You do it all in one step. And what do you get?
1,521.
Okay, so now we have 1,521 equals c squared. And now, how would we solve for c? Does anybody remember?
Do the
Yep.
yeah.
So how do I get rid of a square? I know what you're saying. I can see your arm moving. To get rid of a number or a variable that is squared, we have to take the square root. Okay, so take the square root of both sides. And typically when we're solving an equation, our answer is going to be positive and negative. But why would our answer only be positive on problems like these? Why do we only have a positive answer? Think about it. Can I have a negative value for a side length? No. Okay, so anytime we're talking in terms of measurement, we can't have a negative side length. All right. Okay, so now I want you to go ahead and do this one. All right, we've got 10, 24, and C. Go ahead and solve the second one. All right, so we've got a squared plus b squared equals c squared. Have to write our formula as our original. What's my value for a? 10 squared. What's my value for b? 24 squared equals c squared. What's 10 squared plus 24 squared?
676.
Okay, so I have 676 equals c squared. Now what do? Take the square root. Yes, the square root, and the square root of 676 is 26. So 26 equals C. Did y'all get it? All right, very good. Now in example 2, now we're just going to solve for a different part of the formula. Now, what we don't know is which one, A, B, or C? We don't know a. All right, so we're just going to plug in different parts. So we start with a squared plus b squared equals c squared. And now we don't know a squared. What's our b value? Which one's our b? Is it 10 or 12? Why is it 10? Very good. It's the base, and it's the other leg that is connecting to form our right angle, right? And remember, the legs connect to form the right angle. So that's how we know. Okay, so plus 10 squared. And then our c is always the side opposite the right angle. So I know that that's 12 squared. Do you see how we figured out which number was which? Okay, and now we just evaluate. So a squared plus 100 equals 144. What do we do to solve for a?
Minus 100.
Subtract 100 first before we deal with the square. Now we have a squared equals 44. Well, what happens when we take the square root of 44? That's not a perfect square.
You have to approximate.
Okay, you don't have to approximate it. We're going to go ahead and stay consistent with what we learned yesterday. We're just going to write our simplified answer, and we'll leave 11 under the radical. So 2 times the square root of 11 will be our final answer. Now, we could change this to a decimal form and then approximate our answer. But yesterday, we didn't do that. We just left our answer as long as it was what was under the radical was not a perfect square or didn't have a factor that was a perfect square, then that was fine. So that's the way we're going to keep it today. All right, so 2 times the square root of 11 is our final answer. Think you can do one? All right, try this one. Scratch that, try this one. All right, now you're going to solve for, you're going to solve for b on this one. All right, so we start with our formula, plug in our numbers. Did you plug in your numbers that way?
Yes.
All right, and then we just evaluate to get 400 plus b squared equals 625. Now what do I do? Subtract 400 from both sides. B squared equals 225. Now what do I do? Take the square root of both sides. B is 15. Who got 15? Did I get 15? All right, very good. Now, in example 3, okay, just try to stick with me through the wordy part of it, and example 3 really is pretty basic. But basically, here's what this slide is talking about. It's talking in terms of, what the theorem means. Okay, so a theorem is basically, it can be written as an if-then statement. So you have to have a right triangle in order for the Pythagorean theorem to be true. It can't be any other type of triangle. It has to be a right triangle. So here's what it's saying. It's saying if a triangle is a right triangle, then the Pythagorean theorem will be true. A squared plus b squared will equal c squared. And then the converse of that, what you need to know is the converse means basically we're flipping the statement. If the Pythagorean theorem is true, a squared plus b squared equals c squared, then the triangle is a right triangle. Do you see how they're kind of reversing the statement? All right, and basically this is all it's saying is if your legs, when you square them and you simplify it, if it equals the hypotenuse squared, then it is a right triangle. So we're basically going to test out the theorem. In the first example, we have A equals 3, B equals 5, and C equals 7. And it's always going to be in this order. On your homework tonight, it's going to look like this, where they don't tell you which one's A, B, and C. But just know the first number is your A, the second number is your B, the third number is your C. So going back to the first one, let's plug in the numbers into the Pythagorean theorem. Again, write out the original formula as your original problem and plug in your numbers. 3 squared plus 5 squared equals 7 squared. Well, what's 9 plus 25? What's 9 plus 25? 34. And what's 7 squared?
49.
So is it true that 34 equals 49?
No.
So this one does not form a right triangle because the Pythagorean theorem did not work for those dimensions. All right, you think you can do the second one?
Mm-hmm.
All right, go ahead and try the second one. All right, so now on the second one, we've got 15 squared, make sure you write your original formula, plus 8 squared equals 17 squared. And 15 squared plus 8 squared is what? 289. And what's 17 squared? 289. So guess what? These measurements do form a right triangle because it worked out. Now on the third one, just like I said a few minutes ago, this one doesn't tell me this is my A, this is my B, this is my C. This is like your homework tonight too. So just know your first number is your A, your second one's your B, your third one's your C. Okay? So 12 squared plus 6 squared equals 20 squared. Well, 144 plus 36,
180.
180. Does 180 equal 400?
No.
So you put a line through it and you say no. All right? And if you understand that, that's everything you need to know for 9.3.